This is a graph of the velocity in meters per second of a particle. We don't know what it is. Okay, so when does the body reverse direction? So every y value is of speed. Sorry, I shouldn't say that. Every y value is of velocity. Every y value is of velocity. It's talking about how fast it's moving. So 3 meters per second here. This is maybe 2 meters per second, 1 meter per second. Okay. When is the body reversing direction? Some students might think that reverses direction, but it's speeding up here, speeding up, and then the body starts slowing down, slowing down. Okay, so when does the body reverse direction? It actually reverses direction at t equals 2 because it's still going forward, right? Right here, the particle is meters per second maybe is 2.8. Right here, it's 2.8. It's maybe 2.1. It's 1.1 there. I don't know. Some y values that are just guesses, but they're positive is the point. If you've got a positive velocity, you're still moving forward. But right here at t equals 2, we go from having positive velocities to negative velocities. So we're moving backwards at t equals 2. So still moving backwards because we got negative velocities. Still moving backwards because these are still negative velocities. We switch from negative to positive. So at approximately t equals 7, it also reverses direction. So those are the two places where it reverses direction. When is it moving at a constant speed? It looks to be between t equals 3 and t equals 6. That's a constant negative velocity, so it's backing up at a constant rate. So between negative 3, sorry, not negative 3, that's between 3 and 6 if we use interval notation. In inequality notation, that's 3 is less than t, which is less than 6. Graph the body's speed. So speed is just the absolute value of the velocity. That's all speed is, okay? So it's the original graph when it's positive, but when it's negative, we just got to do the same thing on the positive side of the x-axis. So it should come back down at 7. So this is 7. We're out of negative land. So look, I've just took this and I flipped it up because we took the absolute value of all those negative numbers and made them positive numbers. So there's a quick sketch of the speed. Okay. And graph the acceleration. The acceleration is talking about the slopes of the velocity function. So we're looking at this graph, we're thinking about the slopes. I don't know exactly what this slope is. Actually, I can probably estimate it. Because if that's 1, then I've risen 3 and I ran to the right 1. So an estimate is that we're at 3 for a derivative. Look, this tangent line is following this straight line, so it has a slope of 3. This has a slope of 3. This has a slope of 3. So from x equals 0 to x equals 1, or t equals 0 to t equals 1, we have a slope of 3. And now the acceleration is negative because all these slopes are negative. And again, we could give a rough estimate. This point is 1 comma 3, and this point down here is 3 comma negative 3. So a slope between those points, that's negative 6 over 2, so that's like negative 4. And again, that's just an estimate because we don't know exactly if it changes at that place. So negative 4. All these slopes appear to be close to negative 4. Okay, so between x equals 1 and x equals 3, roughly, those seem to have a slope of negative 4. And then the slopes right here, this slope is 0, right? This slope is 0. So between t equals 3 and t equals 6, we have slopes of 0, so our acceleration is 0. And from t equals 6 to t equals 8, they all share the same slope. And again, we could guesstimate that. That's 6 comma negative 3 for a point, and then this is 8 comma 3. So the slope between those, that's negative 6 over negative 2. So that's a positive 3. From t equals 6 to t equals 8, all those tangent slopes look to be 3. So we're going to have a constant line at 3 on the y-axis. Because remember, the y-axis, that's your velocities on this graph. So the y-axis over here is the acceleration, the derivative of those velocities. So they're all slopes. Okay. And then here we're decreasing, it's negative. I won't bother to guesstimate that one. Maybe I can. I'm being lazy. This is 10 comma 0, right? So that's negative 3 over 2, so that's negative 3 halves. So from 8 to 10, it's negative. So there's a rough graph of the acceleration.